Estimate costs is the process of developing an approximation of the cost of resources needed to complete the project's work. We see a number of tools and techniques here that we'll be discussing over the next several slides with various estimation techniques. The outputs include the cost estimates and the basis of estimates. We have some terminology that's pretty important for you to know for the exam. A fixed cost is an amount of money that's typically paid that does not vary over time. This could be your mortgage payment, your car payment, or perhaps the amount of money that you pay to rent an office. It doesn't matter if you drive that car at all, if you even see that house, or if you've been in that office a single time. The expectation is that you are still going to pay your landlord or your leaser however much money is owed to them. A variable cost is a little bit different in that the amount will fluctuate with time based upon the activity of the business, and it's always going to be somewhat proportionate. For example, if we own a construction company and we are building gazebos, the amount of wood that we'll buy will increase when we have more business, but when activity decreases, we're not going to need to buy as much. A direct cost is an amount of money that we can bill to a specific type of work or a specific project. So if we have somebody whose hourly rate is being billed directly to a project for working on a product, then we can say that, all right, this is a direct cost. All of the money for this person is being provided because they are directly supporting that project or working on that product. An indirect cost is something that is not directly attributable to a particular project. So think about if you have a company cell phone or a laptop, or perhaps the utilities for an office. It's something that, yes, perhaps you are using it towards a project, but at the same time, you're possibly using it for other things as well. With estimating terminology, different organizations will ascribe different numbers to the rough order of magnitude and definitive estimates. But for exam purposes, we do want to know these numbers as they are presented here. A rough order of magnitude is basically a gut check. So in the beginning of a project, if we're tasked with building a skyscraper or a new corporate headquarters, we're not going to know exactly how much it's going to cost. So what we may want to do is try to find a similar project in a similar area and say, all right, well, if that cost about $1 billion, then our rough order of magnitude would be about 750 million to 1.75 billion. Now that's obviously a lot of wiggle room, but that's to allow us to go ahead and do further planning. That allows us to start the conversation at least to see, are they even still interested in something that could possibly be that expensive? In some situations, they may tell you, no, that's entirely too much money. But if they tell you, yes, that sounds about right, then we want to go ahead and start working on our plans. The rough order of magnitude is good during initiation when we do not yet have details, but the goal is to start planning as soon as possible and get to definitive estimates, which are going to be about -5 to a +10%. So we're going to narrow it down as much as possible. The cost estimate ranges will become more accurate as the project lifecycle unfolds. If they're not becoming more accurate, then something is wrong with the methodology that you've selected. The project management plan is an input to this process specifically as we're looking at the quality management plan. So obviously there's a lot of activities and resources that are necessary to ensure that we are achieving the project's quality objectives. And we will talk about the cost of quality a bit further when we get to the plan quality management process. With data analysis, we want to go ahead and analyze our reserves. We will be discussing the different types of reserves, specifically contingency reserves. Cost estimates can include contingency reserves to account for uncertainty, and we would call these activity contingency reserves. Basically, it's assuming that life happens. So if we're saying that we need to buy $200 worth of wood, perhaps we have an expectation that there will be a certain amount of wastage, so we will maybe buy another $20. And that's going to come from risk analysis. That's where we will determine what is an appropriate amount of reserve to put into these cost estimates. With the cost of quality, the cost of conformance is basically what we're paying to ensure that we're building quality into our products. This could include prevention and appraisal costs. With a cost of nonconformance, this is where we did not build quality into our products and then we had some type of internal or external failure, which would mean that either we have captured the fault or it had escaped us and got to a customer. We will discuss cost of quality further as part of the planned quality management process. 3-point estimating involves collecting 3 estimates from the practitioner or whoever may be doing the work. We'll be asking them, what is the most likely amount of money that this will cost to complete? And we can also ask them, what's the best case scenario? If everything goes perfect and there's just absolutely no waste, what would be the optimistic estimate? Or possibly, what is the pessimistic estimate? What's the worst that could possibly happen here? We could use a triangular distribution, which is also known as a simple average. To get the triangular distribution, we're simply doing O plus M plus P and then divide by 3. For a beta distribution, also known as PERT, which stands for the Program Evaluation Review Technique, we're going to take our optimistic estimate plus 4 times the most likely plus the pessimistic and divide by 6. The reason we're putting 4 times the most likely, we're basically saying that the most likely estimate is the most likely to occur, so we're going to put some additional weight onto that estimate. To explain standard deviation will help you as we move forward and begin looking at confidence intervals. What we see here with the bell curve is a pretty standard normal distribution. Normal distributions are symmetric, meaning that from the middle, it is the exact same on both sides. So we do see the Greek letter for mu. This represents the average of the population. And then we see going in either direction, 1 standard deviation at a time. So as we go to the right from the mu, we have plus 1 standard deviation. As we go to the left, we have minus 1 standard deviation. Within the range of 1 standard deviation going either side of the mu, we have 68.26% of all data points should occur right there. As we go out to 2 standard deviations, we have 95.46% of data points. And as we go out to 3 standard deviations in either direction, it'd be 99.73%. Now, this becomes very important because we will calculate standard deviation and use this to help us develop our estimates and the range of our estimates, and then we can go ahead and tell our stakeholders this is our level of confidence within this range. So here we have an exercise. We're going to practice using PERT. We will calculate our standard deviation, and then we will give a range of estimates. So our optimistic estimate, our best case scenario if everything goes perfectly according to plan. This activity will cost $1,800, but the most likely is actually $2,500. But in a worst case scenario, the pessimistic estimate is actually $4,700. So we will do O plus 4 times M plus P divided by 6. This is going to give us $2,750. To calculate our activity standard deviation, we're just going to do pessimistic minus optimistic divided by 6. Typically, standard deviation is a function of variance. However, lacking a true data set, this is a good shortcut, and this is how you will do it for your exam. So we will take the 4,700 minus the 1,800 and divide by 6. So our standard deviation becomes $483.33. The range of estimates. If we need a 68.26% level of confidence, that would be 1 standard deviation. So we will do the expected activity cost plus or minus 1 sigma. Now, if the question called for a 95% level of confidence, then obviously we would do plus or minus 2 sigma. So now we will have a range of estimates from 2,267 to 3,233, or 2,750 plus or minus $483. Outputs from this process are cost estimates. It's going to tell us how much it should cost to complete the project work at the activity levels. And this could be summary or it could be detailed. It's going to depend on the specific needs of the project, but we'll always do it in accordance with our cost management plan. Contingency reserves should be included as part of the estimate. And again, those are your activity contingency reserves. It's possible that we can also include management reserves for unplanned work. All of the reserves should be clearly separated from the estimates, so we should be able to see where one ends and the next begins. The basis of estimates is our way of looking back and saying, how did we come up with these numbers? How were these estimates derived? What formulas did we use? What assumptions did we make? What constraints did we see? What are the possible ranges that we saw, and what confidence level did we have in that estimate? It can also include who did we talk to? When did we talk to them? Did they say that this amount of money would be good until a certain date, and so on. With our project documents updates, our risk register, our assumptions log, and also our lessons learned register. Any one of these could be updated based upon what we observe throughout this process. We've just finished discussing the estimate costs process. Do a quick learning assessment. What types of EEFs and OPAs should you consider here? The EEFs could include market conditions and published commercial data, while OPAs could include the cost estimating policies and templates, lessons learned from past similar projects, and anything else that we could need. What are the pros and cons of the various estimating techniques? So bottom-up estimating is the most accurate, without a doubt, but it is very labor-intensive and very time-consuming. Analogous is very fast, very easy, but also very inaccurate. What information should be included in the basis of estimates? The basis of estimates should include how we've arrived at those numbers, what assumptions, constraints, considerations, possible ranges, confidence level of the estimates. What types of experts should be consulted here? Pretty much anybody that has knowledge on these activities that we're discussing and trying to do estimates for, as well as possibly just financial experts in general. What types of documents could be updated after performing this process? The activity attributes, the risk register, the assumptions log, and also the lessons learned register. What is the purpose of standard deviation in this process? The purpose of standard deviation is to allow us a range of cost with a level of confidence that we're going to fall within that range. So it's going to allow us to ascribe some amount of confidence to a range of estimates.